Good afternoon, Professor Tolo. We speak to you, the student Ruslan Mejia. In this opportunity, I talk about the ATC transponder. Well, the ATC transponder is a system which delocate the aircraft and the maintenance in an effective air traffic inspection from the ground to interrogate at the frequency of 1030 megahertz, and the response of the transponder is performed at the frequency 1090 megahertz. Its main parameters of the system are in mode A, identification. The aircraft asking for the identification by means of fuels. Immediately of the transponder responds with a frequency of 1090 megahertz its identification. And mode C, height. The figures for mode C are given in gray code. Mode S, direction of the aircraft. In this mode A and C are found together. In addition, it deploying the aircraft address code no more than 24 bits. It can be indicating that the S-mode is being designed as a more complete way to ATC system to provide improved surveillance as the communication, right? And the reception in a band other than transmission response signal, the frequency corresponds to to um, to 1030 megahertz. The transmission of the message is giving a frequency of the 1090 megahertz. To perform the operational test of this system, it was necessary to use the following the equipment and our components. Right. First, we have a test bench ABS34. Is this okay? In this module, you can simulate the altitude using the encoder system that works in code gray. This code is used mainly in the position system. It is for this reason that this code is fundamental to insert the altitude. When manipulating and switches of the manual indicate the transponder immediately afterwards sends the selected altitude. It means a visual warning. This switch works with a power supply of 110 VAC and 400 megahertz. It is worth in mentioning the safe system provides information the identification of the aircraft in mode A. Letter B, the RAM test ATC 600 ATC mode. The RAM test simulates the ground station and the can emit the information given given by the transponder in the different modes that you want to work for. It is correct. It will be taking into account that for the mode the GANOP should be positioned in the AC code mode, and for the C mode the GANOP should be in the AC altitude mode. Next, the attenuator. And the attenuator is because the excess the signal caused when the connecting the RAM test directly with the equipment can generate problems, as for example in the level of the signal measured in the big cities, it will causes saturation and noise, for which is necessary place of attenuator, the later reducing the level of the signal to acceptable values for the equipment. Finally, the coaxial cable. When it is a cable transport the frequency, this cable transport the high frequency electrical signals. That does how two concentric conductors. Central one called the core, responsible for the carrying the information, and the outer one with the tubular appearance, which serves as a reference for ground and the turn of the currents. Well, next we have the XPDR. Well, this is important to mention. This model of its series model in the workshop is a KT76A. manufactured with American brand Bendix King. Likewise, the transponder only has working modes and A and C. Okay. Well, we have the button, the ident, a push button. The ident push button serves to generate intermittent light in the PPA of the radars of the ATC controllers. Well, this will be purpose that way to collect and verify that they are truly providing indication to the correct aircraft. The duration of the pulsating signal is approximately and the proximity to 15 or 18 seconds. Okay, the photocell. We have a photocell. Okay, so this is the photocell. Well, in this case, the photocell, the aforementioned photocell does the purpose of the intensifying or the attenuating the indication show on the ATC. Okay, this avoid visual fatigue for the pilot or possible vertigo. The air traffic control radar beacon system, the ATC RBS. The ATC RBS can also allow modifying the code located on the display. This changing depending on the attenuation of the situation. Sorry, of the situation in which the aircraft is located. In or the differential code that provides in tower to AC. The BFR button. What is the show with the use for the button is, but the air traffic controller knows the aircraft that is present. The button mentioned above the knows that is under currently visual flight rules. Well, the function selected node. The function selection node in this function, the selected node there are lots for this model of the XPEN DR. Have a 6 functions with the can be selected with turning in these functions are off. Well, the off, standby, test, ground, on, in alt. In this last, the alt function outputs the height of the aircraft be displayed on the component displaying in additional information. This function is typical of Mod C. Well, to start the TC system test process, it must be taken into account that the transponder located in the laboratory only has a two nodes in mode A and C. For mode A, this equipment in the peculiarity showing the numerical configuration implied is in an octal code in mode A, with the sequence of the lighting according to the number of your column. For example, if you have a number 7, all the lights of your column will light. If you have a 4, only 4, the last light will proceed to irradiate. The transponder has four digits. The parameters of these digits are from to 0000 to 7777. Okay, because they are octal digits. Once there is a response draw the aircraft interrogator will help control as traffic in the organized way. For Mode C, which indicate the altitude at which an aircraft is located, the C mode of the ATC system indicates the altitude in a which an aircraft is located. The selector ganop must be changed to the desired type operation begin in this case the following encoder in which different the altitudes were inserted into gray code. For this, the previously given altitude value is 180 by 1000 and finally divided by 500. The result obtained is located in the code of the table of increments of 500 feet. Recognizes the numbers 1 from the left to the right front. Finally, the last digit of the result will determine the last better of the code. This be the placing in this code table of increments of 100 feet. Then we have these tables, and 500 and the 100 increment. Well, this table we obtained here showed the switches that were activated in the test module in the order to visualize the equivalence and altitude value. Mission mentioned that when the information is presented irregularity of blinking, it means that the equipment is not capturing the information. If the signal will be must proceed to adjust your sensibility of the equipment Um, this sets the output power to show the information without interruptions. Throws is a respective script in the lights its indicates and indication values. If you still have the same problems, there are two other control knobs. Well, okay, you have other two control knobs, and this knob is for the this knob is used for the pulse signals in the 1030 megahertz and response in 1090 megahertz. Okay, so that the received signal is even more clean and satisfactory graduates the width of the other signal the tools. Well, finally, the analysis of the encoder interface of the test bench with the ATC 600 simulator. Well, the encoder has the additional capacity to send the digital outputs to the transport transmission of the ITC. This together with the transponder transmits the altitude of the aircraft in hundreds of feet to the radar of the air traffic control radar system. And line gridder expansion and encoder transmits the altitude of the aircraft to the radar of the attached radar beacon system. It consists essentially of the coding disk that rotates according to the reading of the altimeter. This disk rotation transmits this disk rotation transmits the altitude, and this information is detected by the photographic cells. These digital signals are amplified and transmitted. Okay, the transporter receive them as pressure, altitude. The computer converts this signal based on the local configuration for the altimeter. This ensures that that's there the uniform information regarding all aircraft in the region. It's worth mentioning that these systems work mostly in gray code. Well, and with the respect to the simulated and obtained value, it can be determined that the test and procedure performed on the ATC system were executed satisfactorily. Since the results obtained were expected this bank identification and height codes of the aircraft. On the other hand, it is stressed that it of the vital importance that airs the priority the knowledge about with regard to the code conversion of gray code. Okay, since this will facilitate the process of the testing of the system. In addition, thanks to the analysis of the obtained values, it was concluded that the transponder of the aircraft uses both modes A and C, and to provide a control with a more complete surveillance image compared to the primary radar. It's finally concluded that the present laboratory practice was basically based on the simulation of the ground transponder, on the function on the ground transponder. which transmits the interrogation pulses of the